You know when you look at a map, say of a theme park, in just a couple of seconds you get it. You can see the paths, you can see the buildings you have to walk around. It's just second nature to us. But for some of the most powerful AI on the planet, well, that simple task is a massive, massive challenge.
And that's really the big question we're diving into. How is it that these incredible models, the ones that can write poetry or create stunningly realistic images, get totally lost trying to do something as simple as finding a path from point A to point B?
And this slide just perfectly lays out the problem. On the left, you see how a person does it. We instinctively follow the rules of the space, right? You walk on the path, you don't cut through the gift shop, but the AI on the right, well, it just draws a straight line right through a building. It just doesn't understand the basic rules of the road.
What this all points to is a pretty surprising blind spot in even the most sophisticated AI. It's a lack of what researchers call fine-grained spatial reasoning.
So here's the absolute heart of the issue. The AI is fantastic at recognizing things. It can look at a zoo map and say, okay, that's the entrance and that's the reptile house. No problem. But it can't grasp the relationship between them. You know, the actual winding path you have to walk to get from one to the other. It sees the nouns, but not the connections. So, why? Why does this gap exist? What is the AI missing? Turns out, it all comes down to how these models learn in the first place.
And here's the real twist. It's not about the AI not being smart enough. The problem is its education. It's all about the data it was trained on, or more importantly, the data it wasn't trained on.
Think about it like this. No one ever sat the AI down and taught it the spatial grammar of getting around. Like, hey, you can't walk through walls. The obvious way to teach it would be to show it millions of examples. But can you imagine someone manually tracing all those paths? It would take forever. And on top of that, a lot of the really good, complex maps for places like airports or shopping malls are privately owned, so researchers can't even get their hands on them.
So, with this huge data bottleneck, researchers at Google got creative. They built something truly ingenious, a completely automated AI-powered map factory that they call MapTrace.
The idea behind it is just brilliant. Instead of trying to find and label millions of real-world maps, which we already know is basically impossible, they built a system where AI generates tons of perfect, ready-to-use map data specifically to teach other AIs. It's literally AI teaching AI how to see the world.
This whole pipeline has 4 main stages. It starts by dreaming up new maps. Then it uses a couple of AI critics to make sure the paths are good. It builds a graph of how everything is connected, and finally it generates the routes. So let's break that down.
First up, a large language model basically acts like a creative director. It writes up these really descriptive prompts, things like a fantasy theme park with winding paths and a castle, or a modern shopping mall with a big central food court. Then an image model takes that text and brings it to life as a visual map.
Okay, next, the system has to figure out all the walkable areas on the map. But, not every colorful patch is a real path. So they bring in another AI to be a quality inspector. They call it a mask critic. It looks at the map and their proposed walking areas and basically gives a thumbs up or thumbs down on whether it's a realistic, connected network of paths.
You can almost picture this little AI critic with a clipboard nodding and saying, "Yep, this one's good. The paths are high quality." This AI-driven quality control is the secret sauce that lets them do this at a massive scale.
5. Then, after the system maps out all the connections and generates thousands of possible routes, there's one last checkpoint. A second AI, the path critic, takes a look at the final route laid over the map and makes sure it's logical and actually looks like a path a person would take. It's the final seal of approval.
So this whole automated factory let the team create this huge dataset. We're talking 2 million perfectly annotated maps. But that leads to the million-dollar question. Does training an AI on all this synthetic, computer-generated data actually help it navigate maps of real places?
Well, to find out, the researchers took their new dataset and used it to fine-tune several different AI models. Then they threw a bunch of real-world maps at them that the models had never, ever seen before, and the results were pretty amazing.
Now, before we get to the numbers, we got to quickly understand how they graded the AI's homework. They used a metric called NDTW. All you really need to know is that it measures how far off the AI's path was from the correct one. So just remember, a lower score is better.
And here we go. Look at this. For the Gemini 2 5-flash model, the error score plummeted from 1.29 all the way down to 0.87. That is a huge leap in accuracy. It's clear proof that the training worked.
But it gets even better. The models didn't just get more accurate, they also became way more reliable. And for any real-world use, that might be even more important.
Take the Gemma model, for example. Its success rate jumped by over 6 percentage points. So what that means is not only were its paths better when it succeeded, but it was also far less likely to just give up and fail completely. It got a whole lot tougher.
So these results really confirm the big idea here. Spatial reasoning isn't something these models are born with, but it is absolutely a skill that can be taught. So what does all this mean for the future?
Well, this breakthrough unlocks some seriously powerful applications. I mean, imagine navigation tools that can actually guide you through a confusing subway station, or robots that can find their way around a hospital just by looking at a floor plan. This could even lead to incredible accessibility tools that can verbally describe a route for someone who's visually impaired. Ultimately, what this research shows us is that with the right kind of smart, targeted training, even with synthetic data, we can now explicitly teach AI a fundamental human skill that it was really struggling to pick up on its own.
It's a really powerful new way to think about training AI, and it leaves us with a pretty fascinating question to chew on. Now that AI can finally read our maps, what's the next piece of human intuition it's going to learn to master?